about electricity a little bit? How many of you know at least something about electricity? Show of hands. A little bit. Okay, good. All right. Okay. So yesterday we talked about the fact that there is negative and positive polarities. We're going to start by dealing with DC voltage, which is direct current in only one direction. Then we're going to move into AC, which is alternating current that periodically reverses in direction. Talk about electrons and protons in the atom. The electron is the negative particle of the atom. The proton is the positive particle. Okay? It is the movement of electrons that is the way that electricity actually demonstrates itself. It's how the light bulb comes on. It's how your computer runs. It's how electric motors work. It's by the movement of the electrons. Okay? Now, something important that you need to remember is there are two types of current flow. The one we're going to deal with most is which one? The electron current flow. Okay, electron current flow. Electron current flow is from negative to positive, right? Now, there's another term called conventional current flow. And conventional current flow is considered to be from positive to negative, okay? But since the proton is 1,840 times larger than the electron, it's most likely that the electron is going to move to the proton and not the proton to the electron. Okay? Structure of the atom, we looked at that a little bit. The Coulomb is a measurement of charge. We're not going to deal with that too much, but we are going to deal with volt. Okay? Charge in motion is current. Resistance is the opposition to current. The closed circuit, direct current, sources of energy, and the digital multimeter. Okay? So all materials have both protons and electrons, but when there's an imbalance of these, electricity is demonstrated. Okay, so remember that the proton is positive, the electron is negative. All right? Okay, so to use electrical forces associated with negative and positive, they must be separated. How do we separate them? Well, we can separate them with chemical energy. That's one way. We can take a chemical substance such as acid, and it will separate the electron away from the atom. It'll pull it away. Okay, so we can take a lemon and we can make a battery with it. Take a galvanized nail, drive it into one side of the lemon. Take a copper penny, shove it into the other side of the lemon. All of these electrons that are on this penny will be forced to the galvanized nail by the acidic compound inside of the lemon. Now then, if we take a wire, a conductor, and we put it from our galvanized nail back to our penny, these electrons desperately want to get back to their atom where they come from. They don't want to be separated from their atom. And they want to get back bad enough that they will actually go through this wire, go through all the friction that is resisting them in this element, in this light, and return back home. Of course, this is going to create friction because of the collision of these electrons with this resistance in this element. It's going to glow. It's going to get hot. What happens when something gets hot? It starts to glow, right? If it glows bright enough, it glows enough, it'll light up the whole room. And that's basically how a light bulb works. It's through this interaction. So there's resistance here, which is the opposition to current flow. And we said that was measured in ohms. Okay? Ohms. Now we talked a little bit about the abbreviation and the symbol. Somebody tell me what chart that was and where that was. There you
Page 8.
Page 8, right? Table 1-3, page 8, very important. You need to put your post-it note or something so you can refer to that. Okay? So the unit is the ohm. Okay, unit is the ohm. Okay? And the symbol is the R. Alright? Okay, so Ohm's law is V is equal to I times R. So if we're looking for R, we know that we can put our Ohm's law formula in the circle. Anything we're looking for, we cover it up. So if we're looking for R, we cover it up. It's V divided by I. R is equal to V divided by I. So if I have 10 volts and I have 10 amps, it is equal to, my resistance is equal to 1, not 1 R though, 1 ohm. Okay? Notice here I didn't put 10I, I put 10A. Okay, and that is the difference between the symbol and the unit. So, this is one way that we can separate the electrons from the atoms to create electromotive force. Okay? Another way, we talked about the relationship of magnetism and electricity. Anytime electricity flows through a wire, there is a magnetic field that is rotating around that wire. Also, if you take a wire and you spin it inside of a magnetic field, it will create electricity in the wire. Okay? So Niagara Falls, put you a paddle wheel there that spins, a big ball of wire inside of a big magnet, and it creates electricity. Okay? That was a major discovery, by the way, back in the 17 or 1800s. They didn't believe in that until it got proved that there was a corresponding magnetic field associated with electricity. All right, so the arrangement of electrons and protons. Now what we're really looking for, though, is more of an unstable arrangement if we're wanting a conductor. The arrangement of electrons distributed in the orbital rings around the atom determines the stability of these atoms. So some atoms, like carbon, are pretty stable. Okay? Wood is pretty stable. Glass is pretty stable. Well, these, since they're stable, here's an example of carbon with 4 electrons in the outermost band. It doesn't want to give up its electrons. Okay? And since it doesn't want to give up its electrons, it's not a good conductor. And so what did we say something like that would be called? Amber.
I'm sorry, repeat the question.
What would something be called that doesn't conduct electricity well? Like glass, wood, Stephen?
Insulator.
Insulator, yes, okay. And what do we call copper, water, stuff like that?
Conductor.
Yes, conductor, very good. Okay, so we got 2 major things here, okay? You got conductors and you got insulators. You take a wire, inside of the wire you got a copper wire. That's your conductor. But you don't want to get shocked when you touch it, so you put a rubber coating around it. That's your insulator. Okay? Put 2 of those in one wire. You put 2 wires, each wrapped in insulation, and put them inside of another piece of insulation. You've got a 2-conductor wire. Okay? Put a third one in there that's a ground. You got 2 conductors with a ground. Based on their size, they're given a number. Okay? The smaller they are, the bigger the number. Let's keep it confusing. Let's don't make it simple. Okay, so the bigger the number, the smaller the wire. So a 3-conductor tin with a ground would have a white, a red, and a black, and it would have a ground in there. Okay? And they would be American wire gauge number 10. Okay, now a little bit of residential wiring here. We say the neutral. We say that the white wire is the neutral. But that's not actually correct. It's actually called the grounded conductor, because it also is a conductor. Okay? So, talking about insulators and conductors. Why is something an insulator? Why is something a conductor? Why is copper good at transmitting electricity and rubber isn't? Because of the arrangement of their atomic structure. Because of the amount of electrons that are in their outermost band. Copper has only one. Okay. Any questions? Okay. Not going to go too far in that atomic structure, but here is a list of good conductors: silver, copper, aluminum, glass, plastic, rubber. Okay. So copper is a better conductor than aluminum. Why would they use aluminum? Yes, cheaper. Very good answer. Gold's better than copper. Why wouldn't they use gold? Okay. Carbon, silicon, germanium. There's another element called semiconductors. You'll go to Mr. Ezel next semester for semiconductors. You have a whole course on semiconductors. These are materials that are semiconductive. Under certain conditions, they are an excellent amplifier. Okay? This is where the term Silicon Valley comes from. All the computer inventions and the computer industry in California, it's all dealing with this element of silicon and making transistors. Okay. Here's a list of the orbital rings around the atom. It's in your book if you'd like to refer to that. Always remember that whatever section is listed here on the slide, if you want to know more about that, there's a corresponding section in your book. Okay? All right, so copper, you've got one atom in the outermost band. Okay? The Coulomb unit of charge is a measurement of charge. Now, we're going to deal more with the volt, but you do need to know what the Coulomb is. You may hear that term from time to time.